Okay, so they've got one of these step-by-step questions for us to do. Um, there we go. I gotta scroll all the way down for each part. So they want fx to be expressed as the composition of two functions. So they're saying u of x is 7 minus 2x to the third, and then h of x, that should be x to the negative second. And that's because if this is u of x, that's the entire center of this function inside these parentheses, right? And so if we were to put that inside this h of x function I've created, this h of x is basically putting that negative 2 exponent that we need on top. And so the way we'd write that, let me see if I can zoom in because that looks like multiplication symbol. Okay, that kind of looks like multiplying. So it wouldn't be that one. What's happening is we're putting u into h of x, right? So this is putting u into h of x. So this is the right notation. We're not adding them. This would be putting h of x into u. So that'd be putting negative x squared in here. That would give us 7 minus 2x to the negative 6. So we don't want that one. And then differentiating fx will require the chain rule. Anytime you can make a composition of two functions where you can put one function into the other, we need the chain rule. Gave me a weird dialog box. I'm not a big fan of these tutor me questions, but they're built into our course. So okay, I gotta go all the way back down. And it says let u equal 7x. Okay, so we need the derivative. I think u was our innermost function. Yeah, so this is helping us walk through the chain rule. So the derivative of this is negative 6x to the second, because the 3 comes down and multiplies. And then they're explaining the chain rule, taking it except u. Yeah, so with the function we have here, what's happening is we take a derivative of the outermost function. The negative 2 comes down, multiplies, and it gets reduced to negative 3. And then you multiply that times the derivative of this innermost function times the negative 6x squared that we just found. So the next part they're looking for, this is the du that we just did. And then we need to multiply that by that comes down again. Now we need to multiply it by the derivative of the innermost function that we were just talking about. So that's negative 6x. Oops, x is squared though. And then they moved this negative exponent into the denominator, so the negative 6x squared stays in the numerator. Actually, and that's also being multiplied by negative 2, so that's 12. So negative 2 times negative 6 makes positive 12, and then we got x squared in the numerator. It's still loading. Okay, back to question 30. What is the domain of f of x? So that's this original function. So if we want the domain, we can rewrite it as a rational function. We can move that negative second. We can make that be a positive power by putting it in the denominator. And then we're looking for divide by zero errors. Those are numbers we'd have to exclude from our domain. So we want to find out what it would take to make this denominator equal 0. It doesn't matter if it's squared because 0 squared would be 0. So we can subtract that 7 from both sides. Divide negative 2 from both sides. And then use a cubed root to cancel out the cubed, right? So we get x is the cubed root of 7/2. I don't know if they want us to rationalize the denominator or not, but let's try it because I'd rather not if I can avoid it. The domain of any function is a set of all values of x where the function is defined. The domain is all the numbers that will work for your function, where all the values of x are defined. Since fx is rational, we only need to exclude the x values for which the denominator is 0, just like we just did. Oh, you know what? I bet students don't have to do all this clicking that I have to do. I think I remember the student version is a lot easier to navigate. Us teachers have to keep clicking and clicking. Okay, so we set it equal to 0. What happened here? They square rooted both sides, I guess. and then they subtracted 7 from both sides, and then divide both sides by 2. So that's like what I was just doing. So they divided both sides by -2, I should say. So that gave us 7/2. And then x is the cubed root. How can we do cubed root here? Square root. We don't want that though. Cube root. So there's a 3 and then 7/2. Let's see if it accepts that, because there's a way we could rewrite this so there's no radical in the denominator. And so this is the correct one. Wait a second. No, sorry. That's interval notation. That says only the values between these two. We just need to exclude positive and negative. No, just positive. No, that's not it either. Oh, I don't know where I was getting positive and negative from. No, this is correct. That's what we just solved for. We didn't get an interval like that. Any number works except for the cube root of 7/2. Okay, what is the domain of the derivative? Where's our derivative? This is our derivative. So it looks like it's going to be the same thing because we can't have a divide by 0 problem, right? So where's my symbol? Here we go. Cubed root, 7/2. And then we also need to still exclude 7/2 from the derivative. And I was just going based off that function we had for the derivative. Same denominator, right? Oops, I did something wrong. Okay, let me pause the video. I got something wrong because it didn't let me go ahead. See, I didn't click this one. I absentmindedly clicked the one where I saw 7/2, but it's the cubed root of 7/2. X equals 7/2 is fine. Okay. Step 6, find all values at which the function has horizontal tangent lines. So that's where you'd want to set the derivative equal to 0. So here's our derivative. We want to set the derivative equal to 0 because a slope of 0 is a horizontal line, right? So to solve where the derivative equals 0, we'd want to multiply both sides of the equation by 7 minus 2x to the third all to the third power, because that would cancel out x in the denominator. Because we can't solve for x if it's in the denominator, so that's our first task. Just get it out of the denominator. And then 0 times this whole term makes 0. And then to finish solving, you can probably see that x is going to be 0, right? Divide 12 from both sides, square root of 0 is 0. So it looks like x is 0 is going to be the only places. Now, horizontal tangents occur where the derivative is 0. Since the derivative is rational, this only happens when the numerator is 0. We did this, so that's what I just did on the whiteboard. I'm not sure why it's making us do that twice. We found x equals 0 is where the horizontal tangent occurs. And that looked like the last step. Okay, it's all done. A lot of clicking, but I think it's quicker on the student side.